Another relation that we have to look at is the relation between the sine and the cosine. For that, I'll be working on page 16, so take your syllabus. First, we're going to do a little bit of research. Well, and by we, I mean you. So what you're going to do is look at this triangle ABC with A being 90 degrees, and you're going to calculate all of these values. Now, pause the video and do it. Did you do it? I hope you did. Then you would find these values right here. So, what do you have to remember from this? You have to remember that if you take the sum of the squares of the cosine and the sine, you will always find 1. So mark this. This is what you're going to have to remember, and this is the important part right here. Of course, if we make a statement, we'll also have to prove it. And this proof, you can find it on the next page, 2.2.3. So the next thing you're going to do is try to read through this proof. I think it's very understandable. We will run over this in actual class when I'm back. But do go over this, try to understand it, pause the video now, do it, and I'm sure you will understand. Now, how could we apply this? So I'm on page 18 at this point. We could apply this right here. So if we have an angle of which we know the cosine is 0.5, then we could use that information to determine the tangent and the sine of B using these two relations we've just discovered. And by these two relations, I mean these ones. So the sine of B over the cosine of B should be the tangent of B. Oops. The tangent of B. And then, well, the square of the sine of B plus the square of the cosine of B should equal 1. Now first, we should start off by discovering the sine. Why? Because if we use this formula, we can replace the cosine with the value that we were given. And then we can determine the sine of B. So let's get started. The square of the sine of B plus the square of the cosine of B should equal 1. Now let's replace the cosine with the information that was given. So the square of the sine of B plus 0.5 squared equals 1. Okay, let's transform this equation. So the square of the sine of B should equal 1 minus 0.5 squared. And then, well, we're not looking for the square of the sine of B, we're looking for the actual sine of B. So that should equal the square root of 1 minus 0.5 squared. Remember, if I go too fast at any point, you can slow the video down, you can pause it. And now the sine of B should equal the square root of 1 minus 0.25. So that should equal the square root of 0.75. Now I'm just gonna rewrite 75 to a fraction. So that will be the square root of 3/4, 3/4. And then the sine of B should be equal to the square root of 3/2. Remember, because the square root of A over B, well, that's a weird B, equals the square root of A over the square root of B. That's what I just applied right there. So we found the sine of angle B. Now, let's determine the tangent using this other formula. So the sine over the cosine should be the tangent of B. Well, we know the sine and the cosine, so let's just replace these values with the values that we were given and found. So the sine over B, the sine of B over the cosine of B equals the tangent of B. So the sine of b was the square root of 3 over 2, and then divided by the cosine of b, which was 0.5 or 1 over 2, and that should be equal to the tangent of b. Now let's rewrite this a little bit to a multiplication. So the square root of 3 over 2 times the inverse, right? So 2 over 1 should equal tangent of b. Now, these 2's cancel each other out, and what do we find? Well, the tangent of b equals the square root of 3. So this is how you apply these two relations that we have found.